Stat E, 9.2, confidence intervals for proportions. And I know it says day 2, but yesterday we didn't really take any notes, and I'm not going to have us really take any notes tomorrow as well. What's that sound? Okay. So we're just going to have the 1 day of notes that's going on in here. Tomorrow we'll walk through another problem through our do now, and then tomorrow is actually going to be mostly it's going to be working on a handout after we get done with the do now, so that you can have some paper practice problems. The problems you're going to do today do have a lot of feedback built in, not fully, but there is a lot of feedback built into them to see if you're doing it right and kind of checking with an emoji response, or this is what your answer should look like comment that will pop up, so that you can get some practice with those ones. So the whole point of what we're doing is we want to create and interpret a blank % confidence interval. And when we say blank %, there's some level of confidence that I'm going to ask you to do. Now, of course, if you said that the default, the most common confidence level that we use is 95%. As a statistician, that's kind of our baseline. We want to be at least, or most commonly, 95% confident, which means that about 95% of every possible confidence interval created from the sampling distribution with a sample statistic, p hat in this case, will create a confidence interval, will create an interval that captures what the true parameter is. So, as I just said it very verbally, we're doing this right here. All right, and so when I ask you for an interval, all right, when we ask you for the interval is equal to a sample statistic. Sorry, it's equal. I don't want to use the word statistic. It's a sample. It is equal to the statistic plus or minus the critical value times the standard error of the statistic. All right. Now, because we are working with proportions, our statistic is known as p hat. Okay, so p hat is our statistic. It is the only type of statistic that we're going to have time for in this course. We will run out of, we could also work with other statistics, but the only statistics that we're going to work on from here on out is p hat, the sample statistics. And we should also know that we can calculate p hat as being the number of observed successes over n. Something else that I wanted you to note is that we also refer to this as a point estimate. That's just mostly a vocabulary terminology. The statistic is our point estimate. It is one individual value that we are using to estimate what the population is going to look like. So it's a point estimate. So in doing that, we can also say that because we're saying this, we can say that our interval for proportions P is equal to P hat plus or minus Z star. That's the critical value. We call it Z star. That's what I introduced to you in yesterday's assignment that you were doing while I was out. Times the standard error of P hat. Okay. So this is how we do a plus, we do a minus, but there's a couple of things I want you to know. One of the things that's important to note is that the standard error, when we multiply by the critical value, this is what is known as the margin of error of p hat. Margin of error. And so basically the margin of errors is how far away from our point estimate, below and above, we believe will capture the interval with that level of confidence. So the standard error is one value. When you multiply it by the critical value, z star, this is what is called the margin of error. So when you're doing your work today, and one of the problems is going to ask you to find the margin of error. And so you're like, well, how do I find the margin of error? Well, I already asked you how to find the standard error. More importantly, we get, and this is the final part I'm going to write, because I know it seems like I'm writing the same thing over and over, p hat plus or minus z star times the square root of p hat 1 minus p hat over n. And this will give us our interval A to B. Okay. So that's our formula. That's how we find the interval. Now, of course, the question of, in the problem, you're going to be given n. In the problem, you're going to be given information. You might be given p hat directly, or you will be given the information to find p hat. Okay? Because remember, and this is something that people will often miss, p hat is equal to x over n. So there are situations and problems where I give you x. So if, for example, I said something like 15 out of 80 students said yes. Well, 80 is my n, 15 is my x, 15 divided by 80 is my p hat. Okay? This leads us to the question though. Well, what is, you have this, I wrote this z star. What does that z star mean? So, well, the z star, remember, is how many standard errors away for my point estimate that I'm going to be stepping away. So the most common one that we'll use is 95%. We also have 90% confidence level. That is also the next most common question I'll ask you. 98% confidence. I could ask you for that most. And the last one that I'll ask you for is 99%. And yes, yesterday I know in the Desmos table, and I'm sorry that the feedback wasn't giving you back that if you're right or wrong. I also asked you, I asked you for like 80% and 86%. Those are uncommon values that are actually used for confidence intervals. And I'm not going to ask you one of those questions in our course. But these are the ones you need to know. And as such, the z star for 95% is, this one you should know, this is the most common one. It's not 2, it is 1.96. It's almost 2. We had started off the course saying about 2 standard deviations below and standard deviations above will capture 95%. But in reality, it's 1.96 standard deviations, or in this case, standard errors. All right, so 1.96, that's the most common one we use, and that was the one we've used so far. If we have 90% confidence, we will use 1.645. If it's 98% confidence, you'll use 2.33. And 99% confidence, you'll use 2.58. All right, you should have these written down in your notes because you're going to have to refer to them. Again, I thank you, and I see some good work. I see some increase in note taking. And it's going to take that note taking, bless you, to be successful on this next assessment, which is going to come up rather quickly because we're going to learn how to use. Basically, we're going to do this one more time tomorrow without a calculator. And then I'm going to show you how to use a calculator to make it even faster. You can do it by hand without a calculator. And we're going to make that assessment. It's going to come quickly because we want to do this one and we want to do the one extra one afterwards on hypothesis testing. All right. So, steps. So, we want to find an interval. So the first thing I want you to remember is the first step we do when finding a confidence interval is to check the conditions. Our purpose here is to use a normal model. All right. Does the sampling distribution of sample proportions, is that approximately normal? So we check the conditions. This is the first thing that we ever check. And if you recall, I told you you're going to do this over and over again. How do we do it? Well, there's a mnemonic device that we use. It's a word that you can use to remember the three things. Sin. Very good. S-I-N. Sin. S stands for, what are we checking for S? What do we want to know about the sample? This was on the last assessment. It was on the one before that. So this question's been on 2 exams already. That the sample is random, perfectly. Now, I do want to note that if they do not explicitly say that there's a sample, like a SRS or random in there, then we're going to assume it's random. Yes, I will deduct you points for that. If you say that it is random because you're just regurgitating words back that make no meaning and you're not actually reading the problem, then I'm not going to give you full credit. There will be at least one of the problems where it's not going to say random, and so you're going to have to say assume that it's random. And that's what we do as statisticians for the most part. If nothing says that it's not random, then we're going to assume it's random. All right? If they talk about how they just ask their closest friends, we're going to go, well, that's not random, and then therefore it fails. This is the 10% condition or independence. This is where our sample N is less than 10% of the population. Okay. Now I'm going to put that in quotation marks right in here, the N. So when dealing with a finite population, we do not want to sample more than 10% of the population, because at that point, if we're doing without replacement, I'm selecting this individual and this one, and once we've sampled more than 10%, the probabilities are no longer insignificant in terms of the differences. But as long as we sample less than 10%, it's insignificant. Whoever's phone it is or whatever, please turn it off. And this is our normality check. Which we also call the success and failures condition. So in this condition, we're going to find N times P hat. We want this to be at least 10. And N times 1 minus P hat, we want this to be at least 10 as well. And again, I want to note that this N times P hat is X, the observed successes. So remember, I told you earlier, so if I said something like 18 out of 80 people agreed, 18 is N times P hat. 18 is how many people observed. 18. If this number, now technically, this number right here always has to be an integer. It cannot be a decimal. And the reason is because it's observed. If you get a decimal, you should technically round it to the nearest integer. Okay? Round up or round down. Now, the reason that happens is because if I told you like 60, like I said something like 23% of the students agreed. Now, do you think it was exactly 23%? Probably not. It might be something like 23.124%. That would be the exact percentage. It may even be a decimal number that's irrational. But the problem is, if I told you 21.124% of people agree, you'd be going, why are you so specific? That's a really specific thing. And people don't like to see that. So when we report it, we might just say 21% or 20, whatever it was. Okay? We round it to the nearest. But when you do the calculations, your answer might get, instead of giving you like 18, it might get you 18.2. And you're going to go, oh, it's 18. Now, here's where things get a little sticky. And the work you're doing right now, I am not going to deduct you if you keep it as a decimal, okay? So if you keep it at like 18.2, I'll give you full credit, okay? However, Thursday, I'm going to teach you how to use the graphing calculator as a shortcut. And in order to use that calculator as a shortcut, it must be an integer. And so if you put in a decimal number, it's going to say error. I forget, I'll say error something about, I don't know if it's rational integer or something. It says something like that, integer, and it'll say that it won't do the math for you because it must be an integer. Okay, if all those, if we get check, then that means the sampling distribution is approximately normal, and we can move on to step 2, which is finding the interval. Okay? Now, we're just going to plug into the formula. P hat plus or minus Z star times the square root of P hat 1 minus P hat over N. And this is going to give me some interval A to B. Now, in the Desmos work, I'm going to ask you some additional things. So, for example, in the Desmos, I'm going to ask you what is the sample proportion? That's P hat. What is the point estimate? Same thing, that's also P hat. I'm going to ask you what is Z star? What is the critical value? Just look at that table. I'm going to ask you what is the standard error? That's just this square root part by itself. I'm going to ask you what is the margin of error, which is when you multiply the standard error by that Z star. And then the last thing I'll ask you for the interval and then to interpret the interval. Now, in regards to the assessment, I'm going to keep it pretty straightforward and making sure that you understand what you're doing. So I'm going to ask you just to show your work in finding the interval. I might ask you what was the standard error to make sure that you know the vocabulary, what was the margin. You should know what those values are. If you use the wrong Z star, you're going to get taken a hit. If you can't identify the standard error or margin of error, you're going to take a hit. All right, so you do need to know what the components are. Step 3. Step 3, we are going to interpret the interval. And that's where we use our sentence. We are blank % confident that blank is between blank and blank. All right, and I might have done multiple blanks. I might have said blank of blank and stuff like that, but it's just one long blank in the sense of what we're interested in. So the first one, that's where we put our seed level. We are 95% confident. We are 90% confident. We are 98% confident. Whatever it is that it's asking us to do and what we used. That this is where we enter the parameter info. Okay? As you'll see in the example I do, this is mostly going to be you copying the stem, something that it's going to ask you. What did it ask you to create a confidence interval for? Create a confidence interval for the blank. And you're just going to write those words, the true proportion or the proportion of blah, blah, blah from blah, 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 blah. You'll see it in there. It's literally going to be a copy and paste from that question. Between A and B. And as I said, we're just going to keep it as decimals. We're not going to change the decimal into a percentage. So when I say like, it's between something like, instead of saying 20, it's between 25 and 30%, we're going to keep it as 0.25 and 0.30. We are 95% confident that the true proportion of students who come to school 30 minutes early is between 0.25 and 0.30. We don't know exactly, and it's actually a changing number, right? What percentage of students do come very early to school? That's something that we don't really know the true answer of. So let's do an example. All right, so here's our example. We sample 500 students at random from BPS, from Boston Public Schools, and find that 310 skipped at least one class last week. Okay. Find and interpret a 90% confidence interval for the true, and like I said, I say true, but I'm not going to write the word true, but it's like the true proportion, the proportion of BPS students who skip at least one class a week. Okay. So yeah, it's very wordy in terms of that. I'll give you a little bit of time to copy that down right there. This is the question that we're going to do it. We're going to break it down into its 3 steps. Step 1, checking our conditions. Step 2, finding the interval because the conditions will pass. Okay. If the conditions don't pass, we can't go on to step 2 and 3 in real world. And that's actually one of the bigger problems in practice is that in practice sometimes like you're like, well, I can't move past step 1 because step 1 fails. And if step 1 fails in real statistics, you cannot move forward. You can't, well, something's wrong. I didn't take a good sample. I needed more sample size, all those things. And then we'll interpret our interval. We'll do this example, and then that'll be what we have for today. Okay, that's enough time. So, step 1, conditions. We're going to check S-I-N. All right, S. Does that pass? Yes. Why? Stated random sample. If it didn't state that it was a random sample, then we would assume it's a random sample. Okay, we'll say, well, it's an assumption we make. Now, in real world, in real statistics, that assumption needs to be followed up. And if it isn't really random, we in like actual publicized papers, it's something to note that hey, if it wasn't random, we need to understand that our answer might be might be biased as a result. Well, 500 is less than 10% of all BPS students. And that actually brings me up to all the information up here. This 500 is my N. This 310 is my X. This 90% is my C. Okay, so those are the information that it's given me. N. Okay, normality. This is where I'm going to check the percentages. So N times P hat. Oh, this is interesting. Now, I don't have to find P hat right now. I need to find what N times P hat is. Well, that's 310. That number, 310, is the answer. 310 is N times P hat. That is the number of observed successes. You need to know what N times P hat is. Well, where's the math? Well, n times p hat is the observed successes. So how many people said yes that they skipped at least one class a week? 310. Now, there is a long way to do it. I do want to note some people will go, well, p hat is 310 divided by 500, which is going to give me 0.62. And then they're going to go 500 times 0.62 gives me 310. All right. Well, you already had the answer. But if you feel like you need to find p hat each time and then multiply, feel free to do. You're not thinking, how do you say it? You should always create some shortcuts. You shouldn't try to always go all the way around. Instead of just going from here to here, you're going down here, over here, back up here, and then continuing on. It's not always the best thing. And n times 1 minus p hat, well, that's just how many left over. So how many people didn't skip at least one class a week? That's going to be the 190 students left over. That's at least 10, and that is at least 10. Check, check, check. All the assumptions are successful. Now, of course, from our prior units, we should understand that what we're saying by these conditions passing is that the sampling distribution of the sample proportions is approximately normal. Now, we're not going to worry about the mean and standard deviation of that model because we're going to let the calculator do the rest of the work for us, but that's what that means. All right, step 2. We're going to find the interval. Okay, and we noted that the interval is p hat plus or minus z star times the square root of p hat 1 minus p hat over n. Now, here's the problem here. Now, you do need to know what p hat is now. All right? So, if you didn't find p hat before, you're going to have to find p hat now. I do know some students who just leave it as a fraction, and they'll leave it as 310 over 500. That's going to give you the most exact answer, but it's going to be important. So, what is p hat? Well, p hat is 310 over 500, which is 0.62. What else do we need to know? We need to know n is 500. X is 310. And Z star, remember, we're doing a 90% confidence interval. So what is the Z star that I'm going to use? I'll pause so you can tell me. 1.645. And how did you find that? It's in the notes. Right there. You looked up, you wrote, you've been writing your notes. And if you're one of those individuals who doesn't write their notes, don't be shocked to look at the exam and go, I don't know how to do this. Because you're not taking notes. It's right there. 1.645 because we are doing 90% confidence. Now notice that I don't need X here, but I wrote X right here on this problem because when we get to Thursday, we're using a calculator. You're going to have to use X and not p hat. So that's kind of where, and you have the option. Do you want to do it by hand or do you want to let the calculator do it for you? I'm going to give you that option. You have to choose which one is best for you. You don't have to do both. All right, so we're going to plug this in. So 0.62 plus or minus 1.645 times the square root of 0.62 times 0.38, or 1 minus 0.62, all over 500. I just plug in those numbers. All right, we're now going to go to our calculator. So I pull up my calculator, okay, and I type it exactly what I see in the formula with the minus first. So I'm going to do 0.62 minus 1.645 because we're doing 90%. I'm sorry. Let me clear that. 0.62 minus 1.645 times the square root of 0.62 times 0.38. And I if you want to leave that as 1 minus 0.62, just like we've been doing this whole time, you can do that. Divided by 500 inside that square root, and I get this number right here, 0.584. Okay? Better to go to at least an extra decimal place on there. Usually we go about 3 decimal places. And then I'm going to do the same thing, except for a minus symbol, I'm going to do plus. Boom, there's my interval. There's my 2 values. And I write these 2 numbers down. This one would be 0.656. 0.656. All right, so there's my interval. It is 0.584, comma, 0.656. There's my beautiful interval. And finally, we interpret. Okay? We are blank percent confident. If you do the homework, if you take the notes, this sentence will be ingrained in your head. No, you will not be able to be given a note card to copy it down. But if you've done this, you'll have done about 10, 15 different problems where you have written this statement. And at that point, you know it because you've been doing it. Confident. No, it's been doing it all day. It's like the wind, I think, right there. There's a chair. It's been swinging back and forth. That blank is between blank and blank. All right, we are what percent? What percent confidence are we? 90. We are 90% confident that, now we're going to go back to the problem, and whatever it is that we've been asked to find a confidence interval, find a 90% confidence interval for, and there is my sentence right there. This is my parameter right here. This long piece right here is just what I'm going to copy. The proportion of BPS students who skip at least 1 class a week. And that's what I write. That's my parameter. This is what I'm trying to estimate. Okay? And so I write that. The proportion of BPS students who skip at least once a week is between 0.584 and 0.656. And that's the whole problem. Conditions, find the interval, interpret the interval. All right, but you should also understand why we're able to do these things. I've got a lot of ability because I found out a lot of students who take actual statistics, especially in college, don't know what they're doing. And so when we get into more deeper understanding, you don't know why are we checking these conditions? Well, it's because the sampling distribution needs to be approximately normal. Why are we using the Z-star value? Why 1.96 and why now it's 1.645? Well, because how confident are we? Well, what does that confidence mean? Well, that's about how many intervals we'll create an interval. How many point estimates will create a confidence interval that captures the true parameter, okay? and so forth. And then finally, so that we can interpret it right in here. All right, so that's